All right, so now we're going to do chapter 14. And on this one it says, are the two triangles congruent? And the answer is yes, they are. And let's see how we can tell that they are. So this one, if I were doing the distance formula, it goes, the distance here, you would take this distance and square it, and then take this distance and square it. So this is up 4 and over 1. Well, notice this one is up 1 and over 1, 2, up 1, 2, 3 and over, up 3 and over 1. And this one is up 1 and over 3. So this one and this one would be the same. Okay, this one is over 2 and down 1. This one is down 2 and over 1. So these two would be the same. Now we're not talking slopes here, we're talking distances. So it would be the square root of 2 squared plus 1 squared. And this would be the square root of 2 squared plus 1 squared. All right, and then this one is, let's see, over 1, 2, 3 and up 1, 2. So 3 squared plus 2 squared. And then this one is 2 squared plus 3 squared. So over 2 and up 1, 2, 3. And so this one and this one would be the same. And so by side, 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 they would be congruent. All right, now with the information that they have given us here, this would be the side, side angle property that would show us, because see how it's a side, side, and then an angle that's not included in the two. However, remember, you can't really use that property. On these two, you can tell that they're congruent, but remember, on the side, side angle property, you could actually have two different triangles. One which is an acute triangle that looks like this, and one that is an obtuse triangle that looks like this. And so where this angle, this side, and this side, and this angle, and this side are the same. And remember, so what you're doing is you're taking this and you're swinging it over here, and it forms another triangle. But because these are both acute triangles, you can tell that they are congruent. All right? Problem number 3 says, in the given triangle, MY equals ON equals 2. All right? And then angle A and angle J both equal 70 degrees. And then angle M equals 82 degrees. Now, it says that angle M plus angle A is equal to angle O plus angle J. So what we have is 82 degrees plus 70 degrees is equal to angle O plus 70 degrees. So therefore, if I subtract 70 degrees from both sides, I see that angle O is 82 degrees. And then it says, and they don't really need to tell us this, but angle Y plus angle A would equal angle N plus angle J. And so that tells us these are both 70. So if I take those out, angle Y and angle N are equal. Now we already know that because the all of the angles in a triangle have to add up to 180. And so I could actually figure out what this angle is, because 180 is equal to 82 degrees plus 70 degrees plus X, or angle N, or whatever you want to call it. And so that would be 180 degrees is equal to 152 plus X, and then subtract the 152, and I get 28 degrees is equal to x. So these are both equal to 28 degrees. And so therefore, are the triangles congruent? Yes, because angle, side, angle. Okay? And so you know that they are congruent. Now we're going to look at similar triangles. And so here it says, are the triangles similar? Well, we need to see if the sides are proportional. So 6 over 4, so the longest side here over the longest side here, 6 over 4. And then we need to check the shortest side. So the shortest side here to the shortest, and notice I'm going bigger triangle to little, 6 over 4. So 3 over 2, and that looks good, because if I divide 6 and 4 both by 2, then I would get 3 halves. And then I'm going to check the middle size sides. So 5 and 3. Now notice that is not the same. So these are not proportional. And so they are not similar. Now remember, you can cross multiply. If you cross multiply here, you get 9, and you do 3 times 3, and then 2 times 5 is 10. And they're not equal, so they're not similar. All right, I'm going to do problem number 5 on another sheet of paper. And it shows these two triangles. I'm going to go ahead and separate them out. So they look like two triangles. So it tells me that this side here is 13. This side here is 6, and this side here is 12. All right, and then I want to find, and these are right angles. So I want to find all the sides of the triangles. Right. So on this one, first let's find this side, and I can find this side because this is a right triangle. So I can use the Pythagorean theorem. And so this would be 6 squared plus b squared is equal to 13 squared. So 36 plus b squared is equal to 169. Then subtract 36 from both sides, and I get b squared is equal to 133. And we can't take the square root of that, so we'll just take square root of both sides, and no plus or minus here because it's the length of a triangle, the side of the triangle, so it has to be positive. But we'll just leave it as the square root of 133. All right, so now if I look at this triangle to this triangle, so now I'm doing similar triangles. So if I do the big one over the little one, that's 12 over 6. That's equal to 2. So in other words, this triangle is always going to be twice as big as this triangle. Okay? So this one is 2 times this one. So if I take 13, so this would be equal to x over 13, so I'm going to multiply by 13. So 2 times 13 equals x, and this would be 26. And you can tell, I can just multiply the 13 times 2 because it's twice as big. And same thing here, if I go 2 is equal to x over the square root of 133, multiply both sides by the square root of 133. And so this would be 2 times the square root of 133. Okay, so that was problem number 5. Problem number 6 is talking about a tree. So it says a particular tree cast a shadow 31 meters long on a horizontal ground at the same time as a vertical pole 3 meters high casts a shadow 4 meters long. Calculate the height of the tree. All right, so let me draw it. The shadow of the tree is 31 meters. And again, these are going to be similar triangles because this is a right angle and this is the elevation of the sun at that time. And so here it says a pole 3 meters tall, casts a shadow 4 meters long. And here's the height of the tree. So again, we're going to go big triangle over little triangle. So h over 3 equals 31 over 4, right? So here the h is divided by 3, so I'm just going to multiply both sides of the equation by 3. So I get h is equal to 93/4 meters. Or if you want to use your calculator and get an approximation of that, 93 divided by 4 would be about 23.25 meters tall. Okay, then we have some definitions for number 7. I'm just going to write them out here. The first one is the orthocenter. And the orthocenter is where all of the altitudes intersect. Right? And then the circumcenter and that's where all the perpendicular bisectors intersect. And so it also gives you the point that's the same distance from all the vertices. And so it is the center of the circle that circumscribes the triangle. All right, so if it's like this, and then this is the center. So this distance here, and this distance are all the same. And so you get the circle that goes around the triangle. That's called circumscribing. That's why it's called the circumcenter. But you have to get all of the perpendicular bisectors. And so you would have the center of this one, and then perpendicular from there, and then the center of this one, and then perpendicular from there, and the center of this one, of this leg, and perpendicular from there. And that's how you find the circumcenter. Okay, the next one was the incenter. And it is the angle bisector. For all the angles in the triangle. And it gives you the center of the inscribed. That's why it's called the incenter triangle, circle. Right, so again, on this one you have the triangle, and you're going to bisect this angle, bisect this angle, and bisect this angle, and this gives you the center of the circle that inscribes, is inscribed in the triangle. And then the last one is a centroid. And the centroid is the lines that connect the vertex, each vertex, to the midpoint of the opposite side. And so if I look, here's the midpoint of this one, so I would come across here. Here's the midpoint of this one, so I'd come across here. And then here's the midpoint of this one, so I'd come across here. All right? And this also gives you the center of gravity. Of the triangle, if it's if the shape of the triangle, excuse me, not the shape, if the density of the triangle is all consistent. All right, problem number, and it looks like I numbered these wrong. I'll fix this. So this would be problem number 8. All right. So on this one it says, if the measure of angle 1 is 130 degrees, then find all of the rest of them. Find the measures of the other angles and give reasons why. All right? So first of all, let's look at these 4. So I know that angle 1 is 130, and so therefore angle 2 has to be 50. Now how do I know that? Because they are supplementary. So angle 1 and angle 2 have to be supplementary because they form a straight line. Okay, so I know that this one is 50 degrees. Now, I know that angle 3 is going to be 130 degrees because they are called angle 1 and angle 3 are vertical angles. Okay. Then angle 1 and angle 4 also form a line, so it's going to be 50 degrees. Angle 1 and angle 4 are supplementary. Now, angle 1 and angle 5, okay, angle 1 and angle 5 are corresponding angles. And so they have to be congruent, so this is 130. And then angle 1 and angle 7 are alternate exterior. Angles, and so they have to be congruent. Angle 2 and angle 6. Now, and these you could do so many ways. You could compare them to 7 and 6 would be supplementary, and 7 and 8 would be supplementary. Or I can say 2 and 6 are corresponding, but we haven't used interior, alternate interior yet. So let's do angle 4 and angle 6 are alternate interior. Angles. And then finally, so this would be 50 degrees. And then we can say 2 and 8, angle 2 and angle 8 are corresponding alternate exterior. All right. All right, so now we want to copy an angle. So we want to make this one of the rays of the triangle, so I can either make it come down here or I can make it come up here. All right, so I've got my little pair of scissors that I used last time. So what I'm going to do is I'm going to measure from here, and then the same distance from here. So now I'm going to draw that, and I apologize that I still haven't gotten a compass, but I wasn't thinking about having to do this again until I looked at the page. Then I look at this, and I have from here, I'm going to measure from here to here, and then that has to be the same distance from here to here. And so that gives me, so if I call this A and this B, then this would be A prime, and then this would be B prime. So that tells me this distance from A to B has to be the same as the distance from A prime to B prime. So this gives me point B, and then I can just use a straight edge and draw my line. All right, so that's how you copy that angle. And then if you measure it, this angle and this angle should be the same distance. All right. Now, drop a perpendicular line from point B. So what I'm going to do here is first I need to get 2 points on point B, on line M. So I'm just going to draw this little line here, and that defines A and B. And then I'm going to go same distance from B down to the bottom, and then the same distance from A down to the bottom. And I'm going to see where those two lines, these two little arcs cross. And that gives me point Q, and then I just draw the line from P to Q, and that will be perpendicular. And so I think that's it for chapter 14. Yes, it is. So we'll do chapter 15 on another video.